Hello team! In this lesson we are going to create our first GPA project and learn more about GPA entities. Today we are going to have a lesson full of practical examples and exercises. As you know, I teach students offline and online, and based on my experience after examples that we are going to review today, gradually it becomes easier to understand what GPA is all about. In this lesson we are going to create our first GPA project and learn how to work with GPA entities. We are going to learn today many different annotations that are used to configure GPA entity. Some of them are entity annotation, table, column, ID, generated value annotations. Also, we are going to learn different ID generation strategies. I will explain requirements that we should follow during the creation of our entity class. We'll learn how to work with composite primary keys in GPA entity. I will explain what temporal annotation is and when we might need to use it. Also, we are going to learn what transient annotation is and how to not persist some fields from our entity. In case we will use enums, we need to learn enumerated annotation and learn the specifics of enum types persistence. After we configure our GPA entity, we are going to learn how to persist our entities. I will explain you what Entity Manager Factory and what Entity Manager are. We'll create separate file with GPA configuration. The file is called persistence.xml, and I will teach you what configurations can be placed in there. During the lesson you are going to learn more about transactions in GPA and what transaction types to use during the configuration. We'll compare GTA and resource local transactions. And after learning all this, by the end of the lesson, we are going to have completely working code example that will be able to persist our entity. Isn't this cool? Let's start our lesson. As I promised, this will be a lesson full of practical examples. So let's start from the demo straight away. First of all, let's create separate project for our GPA examples. Our end goal is to practice our skills by making improvements in the online shop template that we developed with my students from scratch in my course Java from Zero to First Job. But we'll learn new topics on the examples in our training GPA project, and only after that we'll work on improvements of our online shop as part of your home tasks. We'll work on implementation of GPA in our online shop together. In Eclipse, I create new Maven project using Maven Quick Start archetype. Maven is not a topic for discussion in this lesson. Please refer to the section about build tools in my Java from Zero to First Job course, where we learned Maven on examples, if you want to learn about Maven more. We'll start learning from understanding of what GPA entities are. I have separate package here that is called entities, and there is a class user inside it. Don't worry, I will share with you all the source code examples that you see in the lesson. Please, find the source code of all examples in attachments to the lesson. Let's learn what an entity is. An entity is a lightweight persistence domain object. Typically, an entity represents a table in a relational database, and each entity instance corresponds to a row in that table. The primary programming artifact of an entity is the entity class. Usually, entities are simple POJO classes. POJO stands for plain old Java object. Basically, data structure with fields and without behavior. POJO usually have getters and setters. After you created a class, mark it with entity annotation. Entity annotation will be used as meta information telling that this class should be mapped with a separate table in the database. The entity annotation is a marker annotation, which is used to discover persistent entities. This annotation is from Jakarta Persistence package. In order to be able to use this annotation, you have to add Jakarta Persistence library into your class path. I use Maven build tool as a dependency manager, so I added instructions to the Maven file to add this library into the class path. And here you can see the dependency in my POM XML file. Table annotation. By default, this entity will be mapped to the user table, as determined by the given class name. If you wanted to map this entity to another table, and optionally a specific schema, you could use table annotation to do that. For example, if you want to map user entity with a table that is called corporate user, then add table annotation like I did here. But I will keep this commented because I want to map user entity with user table. Column annotation. What we need to do next? Now we need to map properties with table columns. Fields are defined as member variables in the class, with the name of each field being mapped to a column name in the table. You can override this default mapping by using the column annotation. For example, in this particular case, we are going to persist the state of the last name field into the last name column with underscore in the name. This is just an example to highlight that you can persist state in any custom table column that you need. I also configured column names for other attributes here. Nothing special, just to make sure that I don't use Java style naming to name columns in the SQL table. Column annotation also allows to specify other meta information about the mapping. Namely, we can specify that the value of some field should be unique in column. Also, we can specify whether the column nullable, insertable, updatable, length. Pay attention to the source code here. You can see that each of these properties have default value. For most of them we can see true, but for the unique, the default value is false. ID annotation. Each entity should have primary key, something what will uniquely identifies each row in the database table and each object in our program. In JPA, we use ID annotation to designate a field to be the table's primary key. The primary key is required to be a Java primitive type, a primitive wrapper, such as integer or long, a string, a date, a big integer, or a big decimal. I just add ID annotation above ID field. Generated value annotation. We can generate the identifiers in different ways, which are specified by the generated value annotation. We can choose from 5 ID generation strategies with the strategy element. The value can be table, sequence, identity, UUID, or auto. Let's review what is the difference between different generation strategies. Table generation. The GenerationType.TABLE gets only rarely used nowadays. It simulates a sequence by storing and updating its current value in a database table, which requires the use of pessimistic logs, which put all transactions into a sequential order. What is pessimistic log? We are going to learn further in the course. But what you have to understand now is that table generation type slows down your application. You can use the table generator annotation to specify the database table which Hibernate shall use to simulate the sequence. The table generator defines a primary key generator that may be referenced by the name when a generator element is specified for the generated value annotation. A table generator may be specified on the entity class or on the primary key field or property. The scope of the generator name is global to the persistence unit across all generator types. The table generator annotation uses a standard database table for primary key values. Sequence generation. The GenerationType.SEQUENCE uses a database sequence to generate unique values. It requires additional select statements to get the next value from a database sequence. but this has no performance impact for most applications. And if your application has to persist a huge number of new entities, you can use some Hibernate-specific optimizations to reduce the number of statements. If you don't provide any additional information, Hibernate will request the next value from its default sequence. You can change that by referencing the name of a sequence generator in the generator attribute of the generated value annotation. The sequence generator annotation lets you define the name of the generator, the name and schema of the database sequence, and the allocation size of the sequence. Identity generation. The GenerationType.IDENTITY is the easiest to use, but not the best one from a performance point of view. It relies on auto-incremented database column and lets the database generate a new value with each insert operation. From a database point of view, this is very efficient because the auto-increment columns are highly optimized, and it doesn't require any additional statements. This approach has a significant drawback if you use Hibernate. Hibernate requires a primary key value for each managed entity and therefore has to perform the insert statement immediately. This prevents it from using different optimization techniques like JDBC batching. UUID generation. Let me briefly cover UUID generation type. UUID stands for a universally unique identifier. It is 128-bit label used for information in computer systems. The term globally unique identifier is also used. Most developers prefer numerical primary keys because they are efficient to use and easy to generate. But that doesn't mean that a primary key has to be a number. UUIDs, for example, have gained some popularity over recent years. The main advantage of a UUID is its practical global uniqueness, which provides a huge advantage for distributed systems. If you use the typical numerical ID that gets incremented for each new record, you need to generate all IDs by the same system component. In most cases, this is sequence for each table that's managed by your database. And if you wanna have identifiers that are unique globally in your system, you can use UUID. On the other hand, the UUID also has some disadvantages. The most obvious one is its size. It's 4 times larger than a numerical ID and can't be handled as efficiently as numerical ID. You should, therefore, decide carefully if you want to use UUIDs or numeric IDs and discuss it with your database administrator. If we are using the default generation type, the persistence provider will determine values based on the type of the primary key attribute. For example, if you use Hibernate as your persistence provider, it selects a generation strategy based on the database-specific dialect. For most popular databases, it selects GenerationType.SEQUENCE, which I already explained. And here's our simple entity class that we created together. Let's learn few more requirements for entity class that we need to remember about. The things that I'm going to talk about now are pretty simple, logical, and intuitive. But just in case, let me quickly cover key points. The class must have a public or protected no-argument constructor. The class may have other constructors. The class must not be declared final. No methods or persistent instance variables must be declared final. If an entity instance is passed by value as a detached object, such as through a session beans remote business interface, the class must implement the serializable interface. Entities may extend both entity and non-entity classes. and non-entity classes may extend entity classes. Persistent instance variables must be declared private, protected, or packaged private, and can be accessed directly only by the entity class methods. Clients must access the entity state through accessor or business methods. And here we generated getters and setters for our properties. Composite primary keys. The next interesting thing that I'd like to explain is about composite primary keys. Probably, composite primary key is not so popular as simple primary key, but still, this case can happen, and I want you to know how to handle such cases in GPA. Composite primary keys are used when a primary key consists of more than one attribute, which corresponds to a set of single persistent properties or fields. Composite primary keys must be defined in a primary key class. Composite primary keys are denoted using the embeddable, embedded ID, and ID class annotations. I have separate class here that is called user composite key. Here you can see that on top of the class I put embeddable annotation. The class has two properties, and this is just for the sake of example. Imagine that the primary key for our user entity will consist from ID and name properties. That's it. And in case you wanna use composite primary key in your entity, you just declare a property of such type and mark it with annotation embedded ID. There is also another way to represent composite primary key. An alternate way to represent a composite primary key is to use ID class annotation. Let me show you another example. I created another demo class that is called project. And imagine that I have composite key for my project entity that consists from department ID and actually project ID. Just as an example. When an entity has multiple primary key fields, GPA requires defining a special ID class that is attached to the entity class using the ID class annotation. Here you can see ID class annotation on top, and I passed project ID class. Let's look at this class. And here I have department ID and project ID. That's it regarding composite primary keys. Temporal annotation. There is important annotation for JavaUtil date and for JavaUtil calendar data types. I'm talking about temporal annotation. Imagine that we need to store date of birth of our user. We can create field of type JavaUtil date or JavaUtil calendar. You can use temporal annotation only with data of such types. In GPA, temporal annotation solves one of the major issues of converting the date and time values from Java object to compatible database type and retrieving back to the application. Pay attention that you shouldn't use temporal annotation with types from Java time package, like for example with local date, local time, offset date time. The mapping between the Java 8 date time classes and the SQL types is implicit. There is no need to specify the temporal annotation. Let's now imagine that my entity has fields that I don't wanna persist. For example, in entity we can have some field that is calculated on the fly. What if we calculate age of the user based on his or her date of birth? And I don't wanna keep age in the database, but still I wanna keep it in the Java object. For cases like this, there is a transient annotation. You have to just put annotation next to field that you don't wanna persist, and that's it. Persist enum types. Sometimes there is a need to persist an enum type. In our particular example, imagine that we have a gender enum. There are only two possible values, either male or female. And enum should be a part of our user entity. We can use the enumerated annotation to specify whether the enum should be persisted by name or by ordinal. You can see that I use enumerated annotation, and inside this annotation I specified that I want to persist string. So basically, male or female value will be persisted. But actually, we don't have to specify the enumerated annotation at all if we are going to persist the gender by the enum's ordinal. But if you want to persist text, we have to specify enum type.